Okay, so we looked at strings and ints, strings being sequences of characters and ints simply being whole numbers. Now let's look at numbers with decimal places, this type being the type float. Actually, for decimal values, there are floats, and there's another type called double. But doubles take up larger memory registers and give you double the accuracy, hence the name. So in other words, a lot of decimal places. But I don't anticipate we'll need to use doubles for numbers with decimal values, so we can pretty much accomplish everything we need with simply using floats. So you declare floats in pretty much the same way you declare ints. So let's do that. Let's go to Visual Studio. And actually, before we do so, let me show you something really neat here to keep your code nice and neat and tidy. You can minimize stuff that isn't relevant for you to have to see anymore. So you can just minimize it by pressing this little plus minus box right here in that whole code block. So this code block with all those commented out portions has just gotten a little bit unwieldy for our custom method called myMethod. So why don't we just minimize that? And actually, since we don't care about the output, don't care about seeing the output for that myMethod being called and output to Unity, we can just comment that out. And now let's make another method that now we can just start from scratch pretty much. So we'll call it myMethod2. All right, not the most creative person in the world necessarily. Sorry with my naming conventions. But anyways, so we'll understand that that's a separate method, and we'll call it up here in the start method just as before, myMethod2. All right, and in this method, our new method definition, our blank slate where we write new instructions, let's declare a float variable. So float x, right? That just sets aside that variable container, nothing in it yet as we did before, and we can put a decimal value now in there. So let's just say 1.9 arbitrarily, and output that to the debug log, just as we have been doing previously. Oh, I have an error. What is my error? Oh, silly me. Yeah, I forgot that for whatever reason Unity strictly enforces putting the F postfix after a float value, or else it just won't work. I'm not entirely sure why that is. It's kind of unique with Unity. The rest of C# you don't necessarily have to do that. But anyways, so now it should work. There you go, 1.9. So now we have a decimal value being output. Mind-blowing stuff, right? Well, here's the thing. Sometimes you have an int and you expect it to return a decimal value when, say, a division takes place, and there'll be a fraction at the end of that calculation. But you start with an int. So let's look at what happens when you try to divide an int value and expect to have the result being a decimal. Let's look at what happens. So type in this. X divided by y, right? So we expect to see x divided by y, 3 divided by 2. We expect to see the result output as what? 1.5, right? All right, let's go to Unity. What do we get? We get 1. That's a curious result, huh? Why do you think we get 1? Well, the reason, again, is we are strictly dealing with whole numbers. So if we get a decimal result after the calculation of 2 whole numbers, the compiler just ignores it. It doesn't round it off. It just chops off, or in other words, truncates the decimal remainder and leaves us with the whole number. Because we're dealing with only whole numbers, ints, it gives us a whole number at the end of that calculation, right? So that's a bit of a problem. If we start with floats, there is of course no issue. If we do the calculation, the exact same calculation, but just change this to float instead of int, and remember f at the end of the values, the peculiarity from Unity. If we do that, it's no problem, right? We get 1.5. That's what we're expecting. But this can be a problem sometimes, because sometimes we start with integers, right? And we didn't realize that we want to end up getting a decimal value at the end of that. So right away we confront a bit of an extra effort and forethought required on the part on our part due to the type strictness of C#. It's not a bad thing, because, as the old saying goes, with one hand giveth and the other hand taketh awayeth. You know what I mean. So you may be wondering, to solve this problem, maybe we can convert the whole number int variable to one that does allow a decimal value. Essentially convert that int to a float, right? What's so hard about that? Turn that 3 into 3.0 and turn that 2 into 2.0, for example. Well, as I said, we can avoid this issue by just starting with floats, but just to illustrate this point, if you do start with an int, you can achieve this conversion with something called casting. Right? Let's show you what that is exactly. So let's put those back to ints. And well, conversions in coding have multiple paths to achieving that end result. It's not always the same, but in this case, it's a very simple process called casting, because the underlying data types are very similar. Integers and floats just aren't that different. So we can perform this conversion by using the option to cast from one value type to another, from int to float. So in order to do that, we simply put in parentheses the variable type that we want to convert to. So let's illustrate this a bit by adding a third variable to store the result of our calculation. Hopefully it'll make it a little bit easier on the eyes as well. So let's make a actually, let's take out the f first. Let's make a third variable, and we'll want it to be a float, z, and we'll assign to it the casting of x to a float prior to the calculation of the cast of float to y, right? So we're taking 3, integer 3 from x, and we're casting it to a float, and we're doing the same with y, and then we're storing that result to the end result being a float to a float called z. And now we can just simply output that to the debug log by referencing z. And what do you know? I'm not lying. That's exactly how it works. So a bit of a simple conversion called casting that you'd have to do in this case, just to show you how that works. Otherwise, you can just get used to the fact that you should treat whole numbers, ints, separately from when you feel that you'll need to use and have decimal places, floats, being used in that case. So one thing that may not be immediately clear here is when exactly the calculation is happening that we have here, x divided by y, and the casting to float. Does it happen when you put z in the log method? Is it just storing the calculation process, or is it happening at the assignment stage? Float z equals and then that calculation. The answer is the calculation happens right at assignment. Kind of referenced this before, mentioning how you read from the right to the left with your variables and the assignments. So just remember that the assignments are operations, right? So the calculation is an operation, and then the equal sign is an assignment operation stuffing that end result into that variable container, in this case z. So that's a quick start on writing instructions in our methods. We declare variables that store some value in memory, and then we perform options on these variables. Calculations, for example, or with strings we saw the plus sign being used as the concatenation operator. All right, so variables we also learned have to be strictly declared with a type prefixed when we declare it. So for now we looked at the int type, the float type, and the string type. And we also showed you a bit of converting from int to float using casting. Just a really quick and simple explanation of that. Now, rounding out our 4 basic value types we have in C#, let's now briefly look at the bool value type. Bools are kind of funnily named and are so called after the logician George Bool, who predated modern computing by several hundred years, but made contributions to the formalized systems of logic, the same system of logic that helped build basically build our systems of coding when dealing with evaluating statements as being either true or false. So this is the same basic foundation that we use when we write code and also understand statements using natural reasoning. So I know it's hip and cool to talk about things being true for me or truthy, and true for you, but when dealing with programming, there's absolutely no such thing. Things evaluate as either true or false, black or white, on or off, 0 or 1, right? It's binary. It's not. There's nothing in the middle. No shades of gray. So you could probably guess that Bools store one of 2 possible values. Actually, first let's make another method definition here. Just keep it separate. Right? And let's comment that out. And let's go my method 3. All right? And in here, I'll show you how to declare a bool value. So let's declare a bool val, all right? And then let's assign it. You can either give it true, a true value, or false, right? That's it. That's all you have with bools, all right? Not truthy, not falsy, not I'm not sure, just true or false. So yeah, bools are really simple to understand, and for this reason, they're heavily used in conditional evaluations for storing states. So you can consider how you may have a platformer where you want your player 1 character to be invincible upon picking up a certain power-up. You can store this state in a bool variable called something like isInvincible. You can name it whatever you want, but that sounds like a good name for it. And so you may start the game with isInvincible equals false, right? And later you grab that power up, and in doing so, it sets isInvincible to true. And you can have another set of code that evaluates that. It's maybe constantly evaluating it. And if isInvincible is true, have a countdown counter, like we saw previously in our prototype demo project. And once that counter goes down to 0, you can flip isInvincible to the opposite value, which is false, right? It's sort of like a simple switching functionality that you get, and bools are very good for doing that. So we'll be showing you that in action a lot in the next few videos as we look at conditionals, but I don't want to overload you too much with too much information right now. And at this point, I just want to conclude our brief look at the basic set of C# value types that we'll be using time and again. We have character sequences strung together, that's strings, whole number integers, ints, and numbers with decimals, floats, and for holding true or false values, we have bools. So also in summary, what we've learned about variables is that we prefix the variable with the data type that you are constrained to what you can store in that variable container. And then you have the user-defined label for that container, your variable name, such as val in this case, so that you can keep referring to it using that name throughout the rest of your code. And we can perform operations on our variables with things like the assignment operator, which is the equal sign, or mathematical calculations, and so on. And then we can combine assignments and manipulate the values that our variables store, hence the name variable in our code. So that pretty much is the gist of the 4 basic value types that C# provides us. We put them together to make more interesting statements that we can evaluate and sometimes branch off with decision-making conditionals. If this evaluates true or false, like remember what I showed you with Bool, then do that. So by using conditionals in tandem with these different operations that we can provide on, we can do with variables, we can start to see how all this together forms the foundation for creating the logic of our game world. So interesting and more game-like stuff ahead with looking at conditionals. All right, see you there.